Today we're going to begin Unit 2. Unit 2 is on linear functions. The first set or first lesson in that is slope. Most of the lessons that we're going to do in this chapter are review from Algebra 1. We're just going to tweak your skills a little bit and extend them into some of the Algebra 2 knowledge that you're going to use for later in the year. So first of all, we need to talk about what is slope. Well, slope is how steep a line is. Now, if you think about that, a line could be horizontal. It could go up gradually until you get all the way up to a vertical line. So we have slopes for all of those lines. Now, they don't all have to go in this direction. They could also go in this direction. And some slopes are positive, some slopes are negative, some slopes are whole numbers, fractions. It just depends on what you've been given. The slope is always going to be the change in y over the change in x. Now, there are some other ways to express that. In calculus, we would say that's delta y over delta x. Your little delta is just kind of the change in. So change in y over the change in x. Another way that we refer to that, and this is probably what you learned in Algebra 1, is rise over run. In other words, if we have a function or a line that is graphed, to figure out the slope, we're going to pick 2 points on that graph, and we're going to count the rise, how far it goes up to get to the next point, over the run, how far it goes across to get to the next point. So when I teach slope, and I've got a little line here, when I teach slope, I teach my students to find a corner point. Find a point on that line that has coordinates that are whole numbers, okay, or integers. And if I look at this right here looks like a corner point, and then this right here looks like a corner point. So I'm going to use those 2 points to figure out my change in y over change in x, or my rise over run. Now, sometimes my students get this confused. They switch these two. They do the run over the rise. Here's how you remember that. Okay, first of all, rise is up and down, okay? Run is across. Well, when you get out of bed in the morning, when you wake up, you have to rise before you can go do your morning workout. So you've got to rise before you can run. That might be a way that it would help you remember that. Looking at this, I always tell my students to start at the lower point that you've chosen and then count up first, and then you will count right or left, whichever direction the slope is headed. So looking at this point, I'm going to count how many spaces it is until I get up to the second point. So let's do that. I've got 1, 2, 3, 4, 5, 6. So my rise is 6. And then from there, I'm going right 1, 2. My run is 2. It's positive 6 because I went up, and positive 2 because I went to the right. So my rise over run is 6 over 2. Now, when we do slope, we will always simplify those fractions. So 6 over 2 is the same thing as 3. So my slope here is 3, or 3 over 1 if we're talking about rise over run. Now let's double check that. If I go up 3 and write 1, is that still a corner point? Yes, it is. So we know we did it right. I just didn't pick the 2 points that were closest to each other. If you pick the 2 corner points that are closest to each other, you will be able to skip the simplification step, okay? But if you don't, it doesn't matter. You're still going to get the same answer regardless. In this example, the slope is going in the opposite direction. So I want to make sure we talk about how that makes the slope a little bit different. I'm going to pick a corner point somewhere on the graph. I'll just choose this one. And then I'll choose this one. And I'm going to count the rise over run. Remember, I always start at the bottom and work my way up. So if I count the rise, that's 1, 2, 3. That takes me level to the next point. So my rise is positive 3. This time my run is 1, 2, 3, 4, 5, 6, and we went left, so it's a -6. So my rise over run would be 3 over -6, which is -1/2. So when your line is headed in the leftward direction, up toward the left, then it's going to be a negative slope, okay? Now, I want to make sure you also understand that if you decide to start your rise from the top and work your way down to the bottom point, you're still going to get the same answer. So let's look at that. If I start here and go down until I get level with the next point, well, that rise is -3. My run is 1, 2, 3, 4, 5, 6, +6 because I went right. So that would be -3 over 6, which is still -1/2. So it doesn't matter what direction you go in, you're still going to get the same slope regardless of whether you start on the bottom or whether you start on the top, as long as you pay attention to the direction that you're moving. I want to make sure I address slopes of horizontal and vertical lines. Here I have a horizontal line. If we talk about the slope of that line, I'm going to, again, just pick 2 points on that line. I'll just pick those 2. And then I want to talk about the rise and the run. Now, if you look at, I'll just pick the point on the left. Am I going to have to go up or down any to get level with the next point? The answer there is no, I don't. So my rise here is going to be 0. I don't have to move anywhere to get level with the next point. And then my run is 1, 2, 3 for that one. So my run is 3. So if you simplify that fraction, 0 over anything is going to be 0. So no matter what the horizontal line is, no matter where it is on your graph, if it's a horizontal line, your slope will always be 0 because there is no rise. You don't have to go up or down to get level with the next point. It's already going to be level. So your horizontal line will always have a slope of 0. That's something you should already have memorized from Algebra 1, but if you don't, you need to commit that to memory. That will save you a lot of time in the future. Next, I have a vertical line. We want to talk about what the slope of a vertical line is. So I'm going to do the same thing. I'm just going to pick 2 random points on that vertical line, and I'm going to count the rise and the run. Well, if you think about it, if I start on the bottom, my rise, 1, 2, 3, 4, in that case. My run, do I have to go right or left to get level with the other point or even with the other point? I do not. So my run is 0. Now, my students often get this confused, so you need to think about what you've got here. 4 divided by 0. If you put that in your calculator, go ahead and do that if you have a calculator with you. Put 4 divided by 0 or 4 ABC 0 if you put it in as a fraction. When you hit that equal mark, it is going to give you an error message. It's going to tell you math error or some form of error, okay? That is because you cannot divide by 0. If you think about what division means, okay? If I had, let me just put right here, if I had 10 divided by 2, what that really means is, how many sets of 2 can I divide 10 into? Well, if you think about it, there's 1 set, 2, 3, 4, 5. There are 5 sets of 2 in 10. So 10 divided by 2 is 5. Well, think about this. How many sets of 0 can you divide 4 into? Can you divide 4 into sets of nothing? You can't, because 4 is something. You can't divide it into sets of 0. So it's impossible to divide by 0, okay? I was always taught in school, thou shalt not divide by 0. All right, so you're not allowed to divide by 0. So if you have something like that, that answer is going to be undefined. Or sometimes we say it has no slope. You can put either one of those for a vertical line, undefined or no slope. And that's always going to be the case when you have a vertical line. The slope will be undefined or no slope. Sometimes they may ask you to identify which slopes are positive, negative, 0, and undefined. So I have an example of that here. You need to understand that if the graph is going up toward the right, it's a positive slope. If it's going up toward the left, it's a negative slope. If it's a vertical line, the slope will be undefined or no slope. And if it's a horizontal line, the slope will be 0. So in this, I might say which line is positive. Well, in that, the positive line is the one that goes up toward the right. That would be D. Which line has a negative slope? That would be the slope that goes up toward the left. That would be A. Which line has a 0 slope? Which line is horizontal, in other words, would be B. And which line is vertical would be C. Okay? Another thing they might do with this is they might say, okay, now that you've identified which ones are positive, negative, 0, and undefined, go ahead and find the slopes. Okay, so if they ask you for that, you would just go ahead and count the slopes. So pause the video, see if you can do that, and then I'll put the answers up here and see if you get them. Okay, so I've got the slopes up here for part A. The slope is -2. If I pick this point, I go up 2 and left 1, which is 2 over -1, giving me -2. For D, if I start here, I go up 2, right 3, so the slope is 2/3. For C, it's a vertical line, so the slope is undefined. And for part B, it is a horizontal line, so the slope is 0. Let's suppose they give us 2 ordered pairs instead of the graph of a line, and they ask us to find the slope. Well, if they give us 2 ordered pairs, we can always graph those ordered pairs and count rise over run just like we did in the last segment. So let's do that. If we go right 2, down 3, and left 2, up 1, and then we draw our line between those 2 ordered pairs, we can count the rise and the run from the bottom to the top. So if I count rise, it's 1, 2, 3, 4. So my rise is 4. My run would be 1, 2, 3, 4. In the left direction would be -4, leaving me with a slope of -1. So this is a great way to do it. If you have a grid readily available, if you can graph it really quickly, that's great. But what if they give you ordered pairs that don't fit on the grid that you have? Like 100, -5, 20, -15. Well, I can't graph that here and get any accurate kind of information. Or what if they give us an ordered pair that has a fraction in it? Well, I can't graph fractions and then be able to accurately just count how far over we're going. It's just too difficult to do. So there's got to be another way to find slope without using a graph. And that's what I want to talk to you about next. Now, if you think about this, in this graph, we said earlier that the slope was the change in y over the change in x. So if you consider these ordered pairs, this one is -2, 1. This one is 2, -3. Okay? Well, doesn't change in something mean what you get when you subtract one of them from the other? Okay, well, let's do that. Now, it's change in y over the change in x. So the change in y is our y coordinate. Okay, and change in means we subtract one of them from the other. So I'm going to start with the bottom one, and I'm going to take that y value, -3, and I'm going to subtract from that the other y value, 1. And then for change in x, I'm going to take the x value on the same ordered pair that I started with before, and I'm going to subtract the second ordered, or the second x value from it. Well, -3 minus 1 is -4. 2 minus -2 is 4, leaving me with -1. Well, what if instead of starting with the bottom point, I start with the top point? We should still be able to do that. The change in y, this 1 minus -3, over the change in x, -2 minus 2. 1 minus -3 is 4. -2 minus 2 is -4, still leaving me with -1. So there must be a formula that we can use to get slope when it's not real easy to graph your slope on a coordinate system. Now, this shows you why it works, okay? This formula will work for any set of ordered pairs that I give you. You can choose two of those ordered pairs, and you'll be able to get the slope between those two ordered pairs. And the slope formula is m equals y2 minus y1 over x2 minus x1. And I always tell my students, well, we have a 0.1 and a 0.2. So if this is my x value for the first point, I'll call that x1. This is my y value for the first point, so I'm calling it y1. This is my x value for the second point, I'll call it x2. This is my y value for the second point, I'll call it y2. And to find the slope, I take y2, which is 1, minus y1, negative 3, over x2, which is negative 2, minus x1, which is 2. And I simplify. 1 minus negative 3 is 4. Negative 2 minus 2 is negative 4, leaving me with negative 1. So it's the same thing that we did here, okay? It's just showing you why it works as a formula. This is a formula you need to commit to memory. Now, it doesn't matter if you start with the second point or the first point. You could start and do negative 3 minus 1 over 2 minus negative 2, as long as you start with the same point on both the top and the bottom. Okay? Now, something you should have learned from Algebra 1, m, anytime we're talking about linear equations, m is your slope. Why did they choose m? I have no idea. Maybe because s looks like a 5, who knows? But m is going to be our slope anytime we're talking about linear equations. So finding the slope when given two ordered pairs should be review. So I've got a few ordered pairs up here, or a few sets of ordered pairs up here for you. You can go ahead, pause the video, do these first 3, see how you do. I'll come back and see if you remember the specifics of the special cases. Okay, now that you've had time to try these, I'm going to do them up here and see how you did. y2 minus y1, 5 minus 2 over x2 minus x1, negative 1 minus 8 would be 3 over negative 9, simplifies to negative 1/3 for the first one. For the second one, 7 minus 7 over negative 2 minus 6. 7 minus 7 is 0 over negative 8. Remember, 0 divided by anything is 0. So that, in fact, would be a horizontal line. And if we graph that, if I just do a little quick graph here, if I go right 6 up 7 and left 2 up 7, if you think about that, those 2 points are going to be horizontal to each other because we went up the same amount. And then in the last one, 10 minus 4 over 8 minus 6 would give us 6 over 2 or 3. I have 2 more for you to try. Go ahead and pause the video and see how you do with those. It's fine to use a calculator when you have fractions. Don't think you can't use a calculator. You can use a calculator as much as you need to. Or Desmos, it works as well. Okay, for the first one, 20 minus negative 1 is 21. 5 minus 5 is 0. Remember, when you have 0 on the denominator, you have division by 0, which you cannot do. So that would be no slope or undefined. For this one, negative 1/2 minus negative 1/4 over 1 minus 1/2. Well, negative 1/2 plus 1/4 is negative 1/4. 1 minus 1/2 is 1/2. And then that would be negative 1/4 times 2, which is negative 2 over 4, or negative 1/2. So that's our review of slope. Hopefully that's enough to get you going on this. We'll do more with slope as we talk about linear equations.